Okay, so we're going to be doing the longest palindrome question for LeetCode number 409. So this one in particular, you are given a string, right? A palindrome, you're trying to find the longest palindrome. Palindrome is just a string that reads the same forward and backwards, and you need to look at this string, which is just complete randomness, and be able to figure out like, okay, what is the longest palindrome we can create with the letters we have here? And thinking about it, you take a second, it's like, okay, so if this is super random, right? And if you reverse the string or whatever, there's no way you're going to get a whole palindrome. Like, you just need to, with the values you have in front of you, kind of be able to figure out if it's a palindrome or not. Well, what is the basis of a palindrome? The basis of a palindrome is if there are multiple of the same letter, right? Because if there's multiple of the same letter, then you can reverse it and, kind of put each letter where it needs to be. So with that thought in mind, it's like, okay, so yes, a palindrome is based off of kind of the letters being the opposite of one another, but it also represents that there are more than one instance of that letter. So now thinking of it as a numbers in like more of like a mathematical terms of sense, right? How can we check if how can we check how many letters are in each number? Well, let's think of a data structure that does that. Well, a data structure that does that is hash maps, right? You're able to get a key and a value. Hash maps are also considered are well known as dictionaries, right? Where you have a key and a value pair. Um, where in this instance our key will be the letter. So let's say our key is D, and the value is how many times it's appeared. So looking at this example, D happens 2 times. So your key is D, and your value is 2 because it happens 2 times. So awesome. Now we know that we need to make a hash map. And we also need to know that we are trying to find um, the max amount of letters that can be used for a palindrome. So we need to have a variable total to hold that answer. So with those things being said, we can already kind of come up with some sort of the code. So we know that we're going to need a variable called total, right? And we're going to set that equal to 0 for the time being. And we know we're going to need a hash map, right, to hold our key and value pairs. And now we need to add values into that hash map, right? How are we going to do that? Well, we're going to do that by looping through our string, which is s, right? So for letters in s, right? Well, we'll just do letter. For letter in s, right? You will do, okay, um, if hash map, right? If hash map, um, or if letter in hash map, right? Then you're going to do hash map at index letter um, plus or equals 1, right? So this is what I was trying to do. And then else hash map at index letter equals 1, right? So you have basically what this is doing is if your letter is inside the hash map already, then just add 1, else just equal to 1. So what this is going to make hash map equal to is, let's look at this example, right? A is 1, and then you're going to have B is 1, and C happens 1, 2, 3, 4. So C is 4, and D is 2. Perfect. So you see that C is happening 4 times, D is happening 2 times, B is happening once, and A is happening once. So now let's think about this, right? Okay, so we kind of already said that if there's multiple of the same values, then they're going to be added, right? That's true, but now you need to think about it. Well, is the length of string, is it odd or even? Because that changes things, right? Because for example, right? You can even take a look at example 2, or not example 2, example 1, right? You have 1, 2, 3, 4, 5, 6, 7, 8, right? So you can have C, 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 D, D, and then, even though these letters kind of seem off, you can have something like this, right? Where it's like C, C, D, D, B, B, and A, right? This example right here is a palindrome, right? Because every single letter is equal to one another, and then even though A is different, because it's in the middle, it is still considered a palindrome because all the stuff around it are equal to one another, and then they land on the same point, right? So we need to be able to kind of write that in code and be like, hey, depending on how much, how many, the length of the string and the amount of instances a certain key has, or we need to incorporate that. So how can we write that in code? Well, what we could do is basically we're going to need a loop through the hash map now, right? So for key and value, and then instead of writing enumerate, which is a function, we're just going to do hash map.items, because when you want to loop through a hash map, you just do dot items. And we want to grab the value. The value. So key is this, and our value is the number. If value divided by 2, so if we have like no remainder, right, meaning like this is perfect, it's a whole number, whatever, then we're going to increase our total sum by our value, right? Oop, didn't mean to do that. Else, meaning that if it's not a even number, we're going to do total underscore sum plus or equal to value minus 1, right? Just to make sure, because if it's just whole and we add the value by itself, right? We have a number in the middle. We want to make sure that we subtract, so we kind of put space for that. And then what we're going to do is make a variable called odd underscore found, and we're going to set that equal to true, right? And then if odd underscore found, right? Meaning, if it was found, then we're going to total sum plus or equals 1, right? Perfect. So with that, we could just return total underscore sum, and I believe this should be it. Let's take a look at our code before we give it a run. Okay, so you have our total sum, which is just a variable kind of holding. You have a hash map, which is where we basically this whole section here stores this in our hash map. You then have a for loop that checks the key and the value of everything within our hash map, right? We're basically checking if the value is a whole number, right? If it's even, we're just going to add total sum by that value, because by that instance, then we should be okay. So that means like 4, right? If there's 4 C's, then add them, right? If there's 5 C's, then we would run this else statement, right? Because it's not even, and that means that there'd probably be a middle number fitting within, right? Just like in this example, the A. So we just subtract by 1, and we set a variable odd found equal to true, meaning like, okay, this is odd. Because it's odd, we're basically going to have a number that maybe fit in here, and it's going to be in the middle. And that's why we add that 1, right? We add that 1 because it's odd, and that the number wouldn't be even. And then with that, once all this is basically checked, these 4 loops are ran through, this if statement has been met, or even if it's not, then we just return the total sum, which is what we've been looking for, and that should return your output, which in this example would be 7. Let's give it a run. Beautiful. Let's give it a submit and see if we checked all the test cases. Oh, no, we didn't. Local variable all found reference before. Yes, yes. Okay. We need to. Sorry, that was just like distinct memory, not even thinking. Okay, so what this error is basically saying is that we have odd found equal to true. How can we set something to true if it wasn't even like called for? It's here. We create a variable, right? The reason for this is because we're starting off thinking, okay, it's not, it's not odd, and we just set it above this for loop. And we're checking if it's even, right? And then let's say, okay, we just discovered it's not even. Set this equal to true because odd found was found, so set it equal to true. And with that being said, odd found will now always be true, right? And because of that, we'll add the 1 so we can fit the room for that uneven number. So let's give it a submit to see if it works now. Beautiful, there you go. All right. So previously everything works. We now know that all we need to do is use the hash map data structure, add values to it, loop through the hash map, and then run these edge cases, which this edge case is basically saying if it's even, then just add the normal value and just chill or whatever. If it's not even, right, that means that we have an example similar to this, where we're going to have like a middle value completely by itself, and we need to set odd found equal to true. And if odd found is true, this is what this is saying, if odd found, meaning if odd found is true, then total sum plus or equal 1. So you just add 1 to our total sum, and we just return it.